Welcome friend to this session of design patterns. In this session, we will try to understand one of the mediumly used design pattern, that is chain of responsibilities. So what we'll do is that we will try to go through fundamentals. We will try to go through a sample source code and try to see that how we can map this same to our live project. So first thing, fundamentals. They fall into the structural pattern categories. As said previously, patterns which fall into structural patterns are those patterns which will help you to solve the structural architecture issues of your class design of your software. So chain of responsibility is used, when you have to do series of processing, and for that series of processing you have series of handler logic. You know. So let me explain you this in detail what exactly this means. Suppose you have a client, and the client sends a request. Now you have series of logics, which are in chain, which can handle this logic. Now it goes to handler one. Handler one analyzes it. Can he process it? If he cannot, right, then he passes to handler two. If he can, then he will process it and pass the request back to the process and pass the response back to the client. In the same way, handler 2 will analyze if he can do the processing. If yes, do the processing, send it back. If no, then send to handler 3. So basically, you have series of logics which are connected to each other, and depending on which handler can solve your logic, it is delegated accordingly. Now what we'll do is that we'll try to complete a sample source code, and try to implement something like this. We'll have a process 1. If process 1 can handle the logic, he will process it. If he cannot, he will pass to process 2. If process 2 can handle it, yes, if he can handle it, he will do the processing or he will pass. So let's try to complete a sample project which will have these three process, and let's try to link them up. If you look at the if you look into the practical examples of COR, web servers are one of the very live examples which use COR internally. Means, for example, take any kind of web server like it's IIS or Apache or any kind of server. Depending on what is the page extension, for example, if the page extension is HTML, it will delegate that the parsing mechanism of that HTML file to a HTML handler. If the page is a JSP page, it will give it to a JSP module. If it's a ASP, it will give it to a ASP.NET uh, handler. So depending on what page it is, right, it starts giving the responsibilities, and e- every of these handlers in, or we can say this, the web server handlers, right, they take up the responsibility of parsing their area. For example, if it's HTML, the HTML will take care of it. If it's ASP.NET, ASP.NET will take care of it. If it's a JSP file, then Java will take care of it. So in this way, there are series of handler logic depending on the page extensions. So this is one of the very practical examples. So again, analyze in your project, do I have a series of handler logic which are connected to each other, and does the request needs to pass through these kind of handler logic? If yes, then use chain of responsibilities. Don't get too carried away. If you have only one or two handlers or one or two logics, processes which are in chain, don't use this because this can probably complicate it. You know, so if you have like lot more logics, like probably 5 or 6 handlers, okay, and tomorrow you want to add a new handler or remove some handler, depending on situations, then definitely COR is useful. So ask yourself two questions before using COR. Do I have these kind of series handler at least above 5 or 6? First question. If the answer is yes, good. Second, do I need to add new handlers dynamically? Okay. And do I need to remove handlers depending on situations? If yes, then again, that means that 100% the COR is the way to go. So as we decided this project, right, we will target on it. So here's what I've done. First, I've created an abstract class iProcess, which every of your process will inherit, or we can say it will inherit and implement this class. In the iProcess, I've aggregated a obj process. Okay, means I've aggregated himself. This aggregated object will define which is the next process to be called. So it is in you can say it's like a linked list. Okay, because if you want that process one should know which is the next process to be called, there should be some kind of link inside the process one. So this aggregated object is the decides which is the next process which will be called. To set which process to be called, we have exposed a method called a set process. So with this, you can set that which is this process you need to call, which is the next process will be called. Now we have abstract method called as run process. This run process will be implemented according to every of the process. Means, for example, process 1 will have its own implementation, process 2 will have its own implementation, and process 3 will have its own implementation of parsing and etc. Now every process, means example, the process 1, let's first take the case of process 1. If his next process is set, okay, if it is not null, he will call that run process of it. This run process will go and call the next process of it. Now here again we will check, we will first do some kind of parsing which is inside process 2. Again he will say, okay, if it is not null, then run this process. That will call process 3 probably. Okay, again the same thing. So we have chain which calls each other in linked list. Okay, now if you look at the client code, right, what we first do is that we create process 1, we create process 2, we create process 3. In process 1 we said that the next process to be called is process 2. In process 2 we said the next process to be called is process 3, and in process 3 we have nothing. So process 1 will call process 2, process 2 will call process 3. Okay, and now we say to the first process, run the process. So if you look at the actual code, it's something like this. The same code which I've discussed on the PowerPoint slide. So here's my abstract class. Here's my aggregated object process, which defines the linked list of the next object to be called. So process 1, I've done some kind of processing of process 1, and if there is a process set, the next process is set, call it. That will call process 2, again the same thing. So if you run this, right, and again my client is this, where we discussed, that first process 1, I've created objects of process 1, process 2, process 3. In the process 1 I have set process 2. In the process 2 I have set that's the next process, process 3. Okay, now if I run it, you can see the first process 1 runs, okay, and it does some kind of processing, and then it delegates and calls process 2. Process 2 then does some kind of processing and then calls process 3, and process 3 doesn't have the next process, so it terminates over there and sends the final response. So this is how COR will work. I hope that I was able to clear a chain of responsibilities pattern to you guys. Again, ask yourself a question: do I have a request which needs to pass through a chain of series handler logics, in a delegated fashion? If yes, then COR is the answer for it. But please, again, as I said, think practically that how you can, do you really need this pattern? Because that is important. If you have only one or two process, it's really of, it will not really give you that benefit. But if you have 10 or 15 processes in linked list, okay, and you want to remove and add new processes, on the series handler logic, then definitely the COR is a way to go. Any doubts, any suggestions, you can always mail me at shiv_koiral@yahoo.com.